Hello and welcome to the show. Today, we're diving into a topic straight out of science fiction, but one that's inching closer to reality: flying cars, or more technically, roadable aircraft. The dream of driving to a point and then taking to the skies is incredibly alluring, promising to reshape how we move, especially in urban areas. But making this dream a reality is a complex journey, filled with significant hurdles. First up, the engineering. Imagine designing a vehicle that's both a great car and a great aircraft. It's a massive challenge. You need a structure that's crashworthy on the road but lightweight for flight. This means using advanced materials like carbon fiber and titanium. Then there's propulsion. Many are looking at electric vertical takeoff and landing, or EVTOLs, which are great for cities as they don't need runways. But EVTOLs gulp power during takeoff and landing, stressing batteries. Hybrid systems are also in the mix. Aerodynamics are another puzzle. Wings are great for flying but clunky on roads. So, engineers are working on retractable wings and clever body designs. And how do you switch from driving to flying? That mechanism needs to be quick, safe, and reliable. Safety systems have to cover both road and air standards. For electric models, battery technology is still a big constraint, limiting flight times often to just 20 to 30 minutes. And we can't forget noise. These things need to be quiet enough for city living. Next, getting these flying cars certified is a regulatory maze. They need to satisfy both automotive safety standards, like FMVSS in the US, and aviation rules from bodies like the FAA or EASA. This dual certification is tough. Plus, global standards aren't harmonized yet, which complicates things for manufacturers. Since much of this technology is new, like distributed electric propulsion or autonomous flight, existing regulations aren't always a perfect fit. Regulators are adapting, but it's a slow, costly process. Pilot licensing is another piece. The FAA actually finalized new rules for powered lift operations in October 2024, covering pilot certification. And how do we manage all these new aircraft in already busy skies, especially over cities? New air traffic management systems are crucial. Public trust is also key. These vehicles must be proven safe. Then there's infrastructure. If we have EVTOLs, we need vertiports, places for them to take off and land vertically. These aren't just helipads. They'll need designated takeoff and landing areas, rapid charging stations, passenger facilities, and maintenance hangars. And building these can be expensive. We'll also need upgraded air traffic management systems, perhaps something like the Unmanned Aircraft System Traffic Management, or UTM, concept being developed. Robust communication and navigation systems are vital, especially for any autonomous operations. Even ground infrastructure might need tweaks for these vehicles. And, of course, a whole new network for maintenance and support will be essential. Despite these challenges, there's a lot of exciting progress. Companies like Aleph Aeronautics with their Model A, PALV with its Liberty gyroplane, Xpeng Aero's modular concept, Osca's A5, Samsung Sky's Switchblade, and Klein Vision's Aircar are all making strides, with some targeting initial deliveries or market releases in the next year or two. Regulatory bodies like the FAA and EASA are actively working on certification pathways too. EASA has even issued design specifications for vertiports. So, while a sky full of personal flying cars for your daily commute is still a ways off, the journey is well underway. Overcoming the engineering, certification, and infrastructure mountains will take time, innovation, and investment. We'll likely see initial uses in areas like air taxis, cargo, or emergency services before they become more widespread. The coming years will truly show us how quickly this transformative transportation technology will take flight. That's all for today. Thanks for tuning in.